Okay, we left off ready for C. We were multiplying. What's the number one thing we have to do in all these problems? We're factoring, right? Okay, so with that in mind, let's jump into some factoring. We've got a lot of it on this particular problem. I already talked about yesterday that the one that's not a fraction, we can make it a fraction by putting it over 1. Okay, so thoughts on x cubed minus 4x? What do you see, Patrick?
We factor out an x.
Okay, start with the GCF of x. So if I factor out an x, what's left in parentheses? X cubed divided by x is x squared, minus 4x divided by x is 4. Now, we can do it now or we can do it later. Do you want to continue with the factoring on this one? Go ahead and do it now. Okay, so I'm going to try and, let's see, leave space here. This x is going to be out front, right? What do we know about x squared minus 4? We did this a couple times yesterday, didn't we?
Yeah.
X squared minus 4 is 2 parentheses. It's the difference of squares. X squared breaks into x and x. What about the 4? Square root of 4 is 2. So 2 and 2, and multiplying to get the minus 4 is plus 2 and minus 2. And you can take this in pieces, however you want. But there's my pieces. Okay. 6x squared minus 13x minus 5. Is there a GCF? There's not an x in common. 6, 13, and 5. Well, 13 and 5 are both odd prime numbers, so no GCF. We mentioned this yesterday. How are we going to have to factor this? Okay, yeah. Product of AC, slip and slide. I don't know what we want to do here, but those type of options, right? What do I need to do? Go over both as a review? Because I know some of you still like your AC, which is good. Okay, that's the more official way to do it. Slip and slide is a good shortcut if you're not a fan of product of AC. So now, where am I going to work this? My notes, I have it done in the middle of the page. I'm not going to sure I'm going to have room. I don't know. In my notes, I have it kind of done here in the middle of the page. We'll try it, I guess. Let me find a different color. Okay. I'm going to work the factoring on the side somewhere here. 6x squared minus 13x minus 5. Whether it's slip and slide or product of AC, it's kind of the same thing in terms of our product. What do we need a product of? AC. So that's going to be a product of negative 30 and a sum of negative 13. This is because we're doing product of AC, right? So what multiplies to be negative 30 adds to be negative 13? 3 times 10 is 30, yes. 3 plus 10 is not going to happen. Okay, now, it's a good tricky one. 3 times 10 is 30, yes? But in order to get them to be 13, 3 plus 10 needs to add to be 13. Multiplying by a negative means we're going to need what kind of signs? A negative and a positive, right? So where 10 and 3, if they're opposite signs, they're going to subtract to be 7 instead. So beware of that, right? 3 and 10, I get it. That was my first go-to also until I started thinking about signs. So 15 and 2, does that work? That one does work, doesn't it? Because now, if you multiply to get a negative, one of them's positive, one's negative. If we add to be negative 13, opposite signs means we're going to subtract. Which way are my signs going? Negative 15, positive 2. So, with that in mind, split your middle term, right? So I'm going to have 6x squared. I'm personally going to say plus 2x minus 15x minus 5. You can put them the other way, right? You can go either way, whichever one makes you happier. Now I have 4 terms. We did a factoring by grouping yesterday up in the top row somewhere. So split this in half. GCF of the first 2. 6x squared and 2x both divide by 2 and x. 2x. 6x squared divided by 2x is 3x. 2x divided by 2x is 1. Okay? Negative 15x minus 5. They both have a 5 in common. Specifically, since that first one's negative, make it negative 5. If you factor out negative 5, negative 15x divided by negative 5 is 3x. Minus 5 divided by minus 5 is plus 1. Okay. This is good news when those parentheses match, right? So, one parentheses is the GCFs of 2x minus 5. The other parentheses, the matching 3x plus 1. Okay. Where am I going to put that? Okay. That was factoring this right here, wasn't it? So it's in the left denominator. So 2x minus 5, 3x plus 1. Because I feel like I need to review it, because I know a few of you like it better. Let me take a brief moment for slip and slide, please. Okay, because I know some of you are definitely like, nope, I do better with slip and slide. So if we talk slip and slide, I'm going to bring it over here. If we talk slip and slide, you can tune out if you're not a slip and slider. Okay? Take the 6 and slide it over, slip it over, I don't know. 6x squared minus 13x, and then 5 times 6 becomes, oh shoot, what did I do wrong? Yeah, that x squared is just supposed to be x squared, isn't it? There we go, sorry about that. Sorry, when you slip the 6 over, it's gone from here, right? X squared minus 13x minus 30. Now, we still need the same product and sum as up here, yes? Product of negative 30, sum of negative 13. So those numbers are still going to be the minus 15, the plus 2. So it's the same numbers we already talked about earlier. Now, what's the final step? We'd originally slid the 6 over. Now, you're dividing them both by 6. Okay? Interesting. Okay. I would encourage you to reduce these. I haven't seen this version of slip and slide. But before you slide the 6 over, do any reducing you can. What do you know about 15/6? They both divide by 3. And so that is 5 halves. Still doesn't go to a whole number, but 2/6 reduces to 1/3. And now, because we need the factored form, take these numbers and put them out front, yes? So the 2x minus 5 and the 3x plus 1. Interesting. I can't say I've seen that version of slip and slide where, yes, you need to reduce it to get the right factors, but it doesn't reduce the whole numbers.
Well, you probably basic.
To each their own, right? And this is where I just don't have enough experience with slip and slide. I'm learning as I go with you guys, okay? So, regardless, you have options. Okay. We're nowhere near done with this problem, are we?
Nope.
Okay. We've got the other fraction still to do. I'll take the denominator. It's 1.
Thanks.
You're welcome.
All right.
You guys get the numerator.
Divide by 3.
Well, that was just right.
Okay. 2x cubed minus 3x squared minus 5x When that last term has an x in it, that's your clue that probably everything has an x in it, doesn't it? So GCF of x, 2x cubed divided by x is 2x squared minus 3x squared divided by x minus 3x minus 5x divided by x minus 5. Okay, so the x is going to carry down right here. 2x squared minus 3x minus 5. That 2 is stuck there, folks. This is going to be a product of AC. It's going to become 2 parentheses, but we've got to do a product of AC to get there. So, or slip and slide. Now, I'm not going to do both this time. Let's just, I'll do the official product of AC. 2x squared minus 3x minus 5 means I need a product of what? Negative 10. If you're slip and slide, you slid the 2 over and you need a product of negative 10, right? Product of negative 10 and a sum of negative 3. So product of negative 10, sum of negative 3, 5 and 2. Multiplying to be negative means I need a positive and negative. Adding to be negative means I need negative 5, positive 2. Split that middle term, right? If you're slip and sliding, you're putting negative 5 and 2 in your parentheses. I'm splitting my middle term. So 2x squared, I personally am going to say plus 2x minus 5x minus 5. I tend to, do you guys look at where the factoring will be better for you? That's what I tend to look at, so. Okay, split it in half. GCF of the first half. They both divide by a 2x. That means I'm going to be left with x plus 1. GCF of the second half. Minus 5. Factor out minus 5. I'm going to be left with x plus 1. 2 parentheses. One of them is the GCFs of 2x minus 5. The other are the matching x plus 1s. Okay. Slip and slide. You guys slid the 2 over and had x squared minus 3x minus 10. You then became x minus 5 and x plus 2. And then you had to put 2 under both of those, right? Okay. Two x minus 5, x plus 1. Well, what do you think?
You cancel out the product.
There's something that cancels.
2x minus 5.
2x minus 5 cancels.
Yeah, you're right. That's deep, though.
Nothing else cancels, does it?
That's all folks.
Okay. So, what's that mean? Nothing else cancels? My answer is all the remaining pieces. Okay, and as I said, you get to leave it in factored form. So we're going to have an x plus 2, an x minus 2. What else do we have? X plus 1. And what else?
Over.
Whoa, whoa, whoa.
Okay. Whoa, brother. Whoa.
I have an x here and an x there. Now, you could put them as x and x in 2 different spots, but ideally, what is x times x? X squared. So what should we do? Make that x out front. X squared. And then I'll say all over the 3x plus 1 you guys wanted to go for. Okay? Will you occasionally run into one with lots of factoring like this? I'm saying you will. Are they all going to be like this? Hopefully no. Okay, real quick. Do we have any restrictions?
Let's just say
I'm out of
no.
space. I guess space.
Well, here, all you have to do is write what can x not equal. You don't even have to show the step here. What can x not equal?
-2, +2.
No?
No.
5/2.
It can do whatever it wants. Yeah, actually, it can be an
Okay. Okay, wait, back up. How do we find our restrictions?
Denominators.
Denominators equal to 0. Anything that was ever in the denominator, yes?
Oh.
Okay.
5/2 or -1.
Okay, so
Yeah, so
we have these two denominators. 2x minus 5 equals 0. And 3x plus 1 equals 0. Solve those each. Add 5. Divide by 2. X is not 5 halves. 3x plus 1. Subtract 1. Divide by 3. X is not -1/3. I didn't even show my step there. Okay? I'm going to hope and assume that we can solve that basic equation at this level. I don't know. I have to be careful there, but. Okay. I started us off rough today. You've seen a little bit of all the factoring in that one problem, folks. Now, officially we still have D here. Good news is D is much easier.
Okay.
I promise it is.
Well, it shouldn't get any harder.
Okay.
It can get harder.
Okay.
It can always get harder.
Let's look at this one. First of all, this piece that's not a fraction, how do I make it a fraction?
Put it over 1.
Put it over 1. Okay, let's start looking at our factoring. X squared plus x plus 10. Is there GCF? No. So we're going to assume that this is product and sum. What do I need? Something that multiplies to be 10 and adds to be 1. What multiplies to be 10? 2 and 5.
1 and 10.
1 and 10. Do either of those give me 1? No. Guess what? It doesn't factor. Leave it as is. I don't know if it's good or bad because it tricks you. But there's no work to do. Other than you did have to at least examine it, didn't you?
I think you're getting a question on testing. Mrs. Sargent, I don't know these factors. Because it doesn't.
Okay. What about x squared minus 49?
7 plus
What he said.
Are we good with what he said?
Yep.
X squared minus 49, difference of squares. X and x, the square root of 49 is 7. If it multiplies, be negative 49, plus minus. X squared plus 9x plus 14.
7, 2.
Oh, does this one actually factor?
Oh, yes.
Okay. It's something's likely to cancel, so. Okay, x squared, x and x, multiplying to be 14, 7 and 2, and they add to be 9. Okay. See, I'm making up for the last one. This one's not nearly as bad. What do you got? Cancel out the x plus 7s. Anybody else? Okay. So, your answer, what are you going to write? X squared plus x plus 10. What else?
Plus parentheses, x plus 2.
X plus 2. What else? Over x minus 7. Notice on top, I put that x squared plus x plus 10 in parentheses, didn't I? And you must do that. Okay? Because we're multiplying it by another factor, I must put it in parentheses. X minus 7 on bottom, why didn't I put it in parentheses? It's the only thing. Okay? I have no problem if you put it in parentheses. I would like to think Sabas would be okay with it because the parentheses don't affect anything, but I'm not going to guarantee that. You know.
Are we doing this chapter until Christmas?
Yep.
Really?
Okay. Did you get any restrictions?
Yes. 7, negative 7.
Okay. Denominator equal to 0, which my denominators were x plus 7 and x minus 7. So x cannot equal positive 7 and negative 7, or plus and minus 7.
So how come one? Where's your one go?
The 1 is just a number. I mean, if we set 1 equal to 0, there's no variable. So since there's no variable, it doesn't matter. Okay, so, bye. So, with that in mind, when there's no variable, it does not matter. Okay, and we had that happen yesterday at some point. I think we talked about it with this 4. The 4, it doesn't have a variable with it. It's not going to make a difference. Okay. Okay.
We have a backside.
We have a backside. Now, we have simplified. We have multiplied. All we have left to do is divide. Now, here's the deal. Dividing has one small difference from multiplication. This is where you have to go back to your elementary days. How do we divide fractions? Because we're not actually going to divide anything today. How do we divide fractions?
Multiply by the inverse.
This is one of those things I never learned how to do.
You have to like flip the second one and multiply.
Keep it, switch it, flip it.
Fractions and long division.
I think I can do it.
Keep change, flip. I'm feeling a little bit under the weather.
Okay. Okay, so as a math teacher, I have to say officially, in order to divide fractions, you multiply by the reciprocal is the word I'm going to throw out there. Now, multiplying by the reciprocal says we're going to keep the first fraction. We're going to change division to multiplication. And what's reciprocal mean? Yeah, flip it. So when you hear keep, change, flip, is that what you guys were taught in middle school? Yeah. Okay. I don't know, my Tipton kids in pre-calc the other day said keep it, switch it, flip it, or something like that. Is that the Tipton version? Okay. As I said, it so happened I had a pre-calc kid with like 3 Tipton kids in there. So, okay. So, here's what I need you guys to remember. Officially, I'm going to write up here. Because again, I'm not doing my job as math teacher if I don't say multiply by the reciprocal. Okay. However, can you also say keep? I'm just going to go with what my TC kids know. Keep, change, flip. That works as well, yes? You do you. What do you remember? Okay. So, with this in mind, I just said you do you, right? I personally, as a teacher, we're going to go through and rewrite this into a multiplication problem before I do my factoring. However, if you are talented enough, which is not that difficult to do, where you want to do your flipping as you do your factoring, you can do that as well. Does that make sense? So I just feel like to be consistent here. So when I say keep, change, flip, we're going to keep 3x cubed plus 6x squared plus 3x over x plus 2. I'm going to change division to multiplication, and I'm going to flip. Now, when you flip, you're always flipping the second fraction. So this is going to become x plus 2 over x squared plus x. Okay? With this in mind, you're ready to factor, folks. This is doing exactly what we just did on the front side. No differences. So, and we are going to have to do restrictions. I'm so not going to have room here. I guess I didn't think my page big enough here, but yes.
If you can already tell that the x plus 2, x plus 2, they're already going to cancel, can you just take them off right now?
Sure. Yeah. I'm not against it. I'm going to save all my canceling for the end, but yeah. They're going to cancel, I agree. Okay, what about this 3x cubed plus 6x squared plus 3x?
Probably C.
No, we factor out the x.
Oh, you can divide it all by 3.
Oh,
And then
yes.
Okay, are we there? GCF. That's what I need you thinking. It took a moment. We got there. GCF. Some people saw they all have a 3 in common. That's going to be really helpful. So get us out of product of AC. They also all have an x in common. So 3x. 3x cubed divided by 3x is x squared. 6x squared divided by 3x, 2x. 3x divided by 3x, 1. Well, that made life a lot nicer, didn't it? And it's still going to be, in my book, over x plus 2. Paul's already canceling the x plus 2's on me. That works. Now, am I done with factoring that numerator? No. We're not quite there. So I'm going to go ahead and we'll go back at the second fraction in a moment. 3x stays 3x. What do you know about x squared plus 2x plus 1? X squared is x and x. What are we multiplying to get there? 1. What multiplies to get 1?
1.
And what do we know about 1 and 1?
Add them together, equal 2.
Add them, they get equal 2. Okay. I hope you're saving room for restrictions because I don't know what I'm going to do about restrictions. Okay. On the second fraction, we already flipped it. X plus 2 is on top. What about x squared plus x? It's only 2 terms.
Oh, just
Think GCF of x. If I factor out GCF of x, x squared divided by x leaves me with x plus x divided by x is 1. So that second fraction is x plus 2 over x times x plus 1. Well, there's some good news here, isn't there? There's a lot of good news, actually, if you catch it all. What cancels?
X plus 1.
Okay. 1x plus 1 cancels with 1x plus 1.
X plus 2.
1x plus 2 cancels with 1x plus 2. And 1x cancels with 1x. Because keep in mind, we talked about this yesterday, that 3x is 3 times x. Those are pieces multiplying together. Can I cancel that x and still leave the 3? Yes, I can because they're multiplying. I don't even know where I'm going to put my answer because there I'm going to be. What remains?
3 parentheses.
Okay, the 3 and the x plus 1. All over 1. So I'm just going to say 3 times x plus 1 because it fits fine on my paper and pencil. It's on the BenQ, it did not fit fine. So
Restrictions.
now, restrictions. Remember what I said yesterday about restrictions. Restrictions. Anything that is or ever was in the denominator. Okay?
Just negative 2.
Well, we gotta do x squared.
Yes, he did x plus 1. So, be negative 2 and negative 1.
Okay, so yeah, here's the catch here, guys. Anything that is or ever was in the denominator. So when we start looking at pieces who are in the denominator, up here my problem started with x plus 2 and x plus 2, right? So one of my restrictions is that x plus 2 cannot equal 0. But then what did we do? We flipped it. And this x squared plus x became x and x plus 1. Right here is the best place to look to get the rest of your restrictions, okay? So we've got to look x plus 2 from the denominator of the first fraction. In the second fraction, you're looking at numerator and denominator. X plus 2 is already covered, and then what else do we need to include? x plus 1 and does x matter? It's a variable. So are you with me here? I'm not sure you're happy with me, but are you with me? X cannot equal
I'm always.
-2, -1, and 0.
I like it.
Okay. So the division, you have to remember to flip the second fraction. You have to make sure you get all of your restrictions. But other than that, it's the same type stuff. Okay. Let's practice another division. Just a party?
Tissue party.
Tissue party. Okay. You can factor as you go if you want. I'm going to start off by making my first step what? Keep, change, flip. Whatever your variation is, right? Okay, so 1 over x squared plus 9x. Division becomes multiplication. Fraction flips. So 3x squared minus 18x over 6 minus x. Okay. Well, I got the 1 for you.
Thank you.
I know, I'm being so helpful here, aren't I?
Yeah.
Yes,
Why is it in parentheses? Does that matter?
it is not.
Okay.
Okay. It's just, for whatever reason, sometimes they put it in parentheses, sometimes they don't, so I tried to match that form on here that they can be, they don't have to be. Notice when I rewrote it, did I put the parentheses? I didn't. Okay. Okay, 1 is 1. What about x squared plus 9x?
Factor on x.
It's 2 terms. They both have an x in common, yes?
Yep. Yes.
So, GCF of x squared divided by x is x. 9x divided by x, 9. 3x squared minus 18x. 3 and 18 both divide by 3, and both terms have an x. So let's factor out a 3x. 3x squared divided by 3x is x minus 18x divided by 3x, 6. Now, 6 minus x. Anytime I see that, I know there's a catch. Think for a moment. If I write 6 minus x, is this the same as negative x plus 6? All I've done is taken my pieces and flip them, yes? What GCF would we talk about there being? A negative 1. Now, is this going to be beneficial here? If I factor out negative 1, negative x divided by negative 1 becomes positive x. 6 divided by negative 1 becomes minus 6. Was that beneficial?
Yeah, it's because it makes you cancel.
That's what I need you to see. There's a canceling piece there, yes?
Oh.
Right on top of it.
Oh.
I thought,
You guys really weren't seeing that, were you?
I was lucky enough to go across when I did it.
No,
Nope.
you just can't do it on
On
It's
some.
uploaded to.
Okay.
What?
Sure.
Let's see, we got everything factored, right? So, okay, what I'm going to say about that 6 minus x, when you see something like that in reverse order and they're subtracting the variable, my suggestion is flip it around and factor out that negative. That's what you're going to need to think about, okay? Now, what cancels? Okay. X minus 6 cancels with x minus 6.
X with the 1 through X.
Okay. And x on bottom cancels with, when this is 3x, we can cancel x and x. The 3 is going to stay, isn't it? Okay. Anything else cancel?
The ones don't cancel, do they?
No.
They're just ones. I mean, they're going to be there regardless. So, okay, what do we have on top? The 1, which doesn't really matter, and we have a 3. In the denominator, what do we have?
X plus 9 and negative 1.
Okay, x plus 9 and negative 1. Now, one option is the negative 1. You can write out front of a set of parentheses, x plus 9. You can also distribute it in. I have it like this in my notes, so I would like to think that that would be acceptable in Savas.
So distributing it, it'd just be negative x minus 9.
Yes. 3 over negative x minus 9 would be equivalent if you did multiply that out. Okay. Have you checked restrictions? Anything that ever was or is in the denominator.
Negative 9, 6, negative 6.
I'm writing what the factors are. Okay, so this 1 over x squared plus 9x, what did it become? It became x plus 9 and
And 0.
we had an x there, yes? So that's this first denominator. Now this one, originally 3x squared minus 18x was in the denominator. Well, that's the x, the 3x, which is x, right? So same as this one. X minus 6, which is what I already have here. 6 minus x. Well, 6 minus x, I mean, you could set 6 minus x equal to 0, but here's the deal. It's the same as x minus 6 with a negative 1 factored out. So that one's not going to, it's just going to be a duplicate. Okay? So you do end up with 3. X cannot equal negative 9, 6, and 0. Okay? It gets a little touchy with division, doesn't it? Okay, in terms of keeping all the variable restrictions straight. Okay.
Don't talk about
I don't like division.
How about
Well.
we do it tomorrow, then we have a one day?
That would be so
Yeah.
such a good way to
Like
wrap up the
great
week. Let's
days.
do it. And
A great way to go into
Yeah, that'd be so sweet of you.
Okay.
I'm trying to learn.
2x squared minus 2x. There's only one factoring that has to happen here, folks.
oh,
There's a GCF of 2x. Leaves me with x minus 6 over x plus 5. Because it's division, we're going to multiply by the reciprocal.
Long story short, you only get 2x.
Okay. That's, yeah.
Do you see why I said I'm going to go ahead and throw it up here?
Then your restriction would be
X plus 5, x minus 6 cancels.
negative 5 minus 5.
You're left with 2x.
So your restriction.
In terms of restrictions, it's the denominators, which were only the x plus 5 and x minus 6. Because that 2x was never in the denominator, was it? So x cannot equal negative 5 and 6.
We should have saved one of the hard problems for our last one, so we didn't have room.